Hello, everyone. My name is Clifford, and thank you very much for joining me today. What I'd like to do today is just take you for a demo view and a code walkthrough of a very basic decentralized finance app that I've been working on. Really something I would describe as a digital bank. So yes, just for a quick background. I'm currently learning about blockchain and cryptocurrencies. It's been something that I've been interested in for a while now, and for that long I've been finding it very fascinating. It has a lot of use cases. It's promising a lot. It's promising a lot for the world. It's promising a lot for Africa, especially Africa. Some promises other people say, they sound too good to be true. But honestly, I may be biased. I may be biased by saying this, but I really think that with the right expertise, we can get there. And then in terms of with my learning, I've come through different concepts in Web3, and one of those, which is one upon which I based my app here, is called staking or yield farming. So in essence, staking and yield farming is very similar to banking. And since I'm describing the project as like a digital bank, it's similar to a digital bank in a sense that you get incentivized, you get interest via tokens by holding tokens yourself. So it's like a savings account, but for cryptocurrency. It's a very, it's more detailed than that. I think I'll do a better job. It's more detailed than that. It's a very common trend right now in the Web3 space. I know Brave. So Brave is a Web3 search engine. I know that it is incentivizing its users to use the site itself. So yeah, you're getting tokens for using Brave. And I guess that's a side income idea right there. So in terms of the app itself, I used Truffle. Truffle is a Solidity framework that we use in the backend, and also used Solidity, of course. Solidity is a language that we use to build smart contracts, and shortly I'm going to explain what those are. And then I'm also using MetaMask as my cryptocurrency wallet, and also using a simulation called Ganache that we use for simulating a blockchain. I'm just going to show those now, just shortly. So that's me in the back end, and then in the front end, I went with HTML, CSS, JavaScript, and React. Excuse me. So what I like to do now is go on with the preview of the app, and then after that, it would make sense for me to go to dive into the code walkthrough. Excuse me, to dive into the code walkthrough. But I think as much as I'd like to keep this video short, I think it would be best that I also give like a short description of how the blockchain works. So I'm going to do that after showing the preview of the app, because I think it's really key that we understand how the blockchain works, because I know it having that understanding did help me understand the code itself. Because, for example, I mentioned MetaMask wallet and Ganache, which is the blockchain itself. So when we are understanding how those things work, it's very helpful because those two are incorporated in our code itself. And going to show that when I go through the code. So just quickly to go for the preview of the app. So I'm gonna need to disable my camera, this current camera, and open a different app that's gonna help me view the presentation and also view myself down there as well. So I'm just gonna quickly disable this, enable a different one, and then share my screen like that. Okay, I'm just gonna quickly hide this. Drag myself down there. So I said like the concept that I used to build the app is staking or yield farming, and you guessed it, I named my app Stake a Lot. So this is the UI of my app. In our right hand corner is the MetaMask address, or just your Web3 address. So Web3 address really is I can describe it as similar to a bank account, like in traditional banking. It's a bank account. When someone wants to send maybe Ethereum or Bitcoin to you, they want to address that to your Web3 address. So that's the hashed number there. And then here, so for the entire app, I had to create tokens. That needs a video in its own, really. But you create tokens using the ERC-721 protocol. So it's like a guideline that you use to create your tokens. So I created 2 tokens, named one Pro-T token, and then named the other one Ubuntu token. And then, so this here is going to be my staking balance. So the staking balance is going to be the amount of tokens that you have deposited into the staking app, and then the reward balance is the interest that you're going to be gaining by saving your tokens with the app. So this is going to be my user interface. I'm going to stake here. Then unstaking is withdrawing from the account. It's withdrawing from the app itself back into your account. And then these two buttons are going to be incorporated with MetaMask, so you confirm all of those transactions. And then this address here. So we currently seeing a balance of 0 here, because I was using this address with a different Ganache. Like I closed my Ganache just so I can show like the entire process of importing an account into MetaMask. But then we're seeing a 0 because it's practically erased. So each time you open Ganache, it comes with new accounts. But I'm gonna quickly go through the process of that's why I didn't close it. I want to close it and then show the entire process of deploying your contracts on there, and it's in the whole 9 yards. So let me see. So the first thing we need to do is let me quickly show Ganache. So Ganache is essentially, it's a simulation of a blockchain. It's a local blockchain that we can run. It helps us visualize what happens on the blockchain when you're making transactions. Because well, essentially a blockchain is, I can describe it as like a ledger or like records on the internet, and it's decentralized. Every computer on the blockchain, which is also called nodes. Every node on the blockchain has access to this record, and if there's a change that happens, each of those nodes is aware of that change. Put very briefly. So this here helps us simulate all of that process. So what I did before the video, so I made just a few transactions. It wasn't even a lot of transactions. I think I was just deploying the smart contracts onto the blockchain, and then everything gets recorded. So let me just transactions. So each and every transaction has information. So this is block number 7, for example, and then there's a kind of information that we find in a block of our blockchain. So we find the sender address and the two contract address. The gas price. So gas is like a charging fee for making transactions on the blockchain. When you're making any transaction on the blockchain, you get charged a fee, and then yeah, that's essentially a block. Then these are different accounts. So we just have 10 accounts for testing. Each account comes originally with 100 ETH. It's not real Ethereum. It's test Ethereum. But yeah, it's quite useful. I've been finding it to be very useful. And then yeah, let me just quickly simulate that. So firstly, so I'm just gonna, because what you need to do is, and I'm gonna explain all of that with the code, but essentially we put our smart contracts in a blockchain, and then create instances of that smart contracts, like JavaScript instances, and then we're able to interact with the smart contracts via a user interface, a JavaScript user interface. So I'm just gonna restart. I'm just gonna close everything, just so I can show the entire process of importing an account into MetaMask. Just gonna do this. Open my Ganache again. So we need to have our Ganache running, so that we can, before we do anything else, because in my scripts there I declare that I want to deploy my contracts into Ganache, because you can deploy your contracts to different networks. So we have a fresh Ganache running now. Each account has 100 ETH, test ETH, and then I'm just gonna log into my MetaMask now. So just put myself down there. Here's my MetaMask here. So MetaMask is your cryptocurrency wallet. So it holds your crypto. So these are just imported accounts, and if you just see the zero value there, that's why we're seeing a zero before, because when I closed the Ganache, it also it sucked up all the Ethereum that were in these accounts. So I'm just gonna import new accounts. First, gonna delete these ones just to remove them quickly. And then, so for you to, an address comes in, like your blockchain account comes in two forms. There's a public address, and then there's a private key. So your private key is the one that you use. It's again parallel to banking. Your private key is like your password. So both those information, you can access them by clicking on the key here. And then you're seeing the address, which corresponds with your public address here. And then this is your private key. So to import an account or to log into MetaMask, we're gonna import our private key. And then when that's done, we're going to import here. Okay, so we sorted, that's 100 ETH, and then let's try to let's import another account so that we show the changing hash address on our task, on our navigation bar, on our user interface. So I'm just gonna get another account here. Come into my MetaMask, import account. There we go. So this account here, this is a default account that comes with MetaMask. And then these two I imported, so I can't delete this one. It's a default account. So we have two accounts that both have 100 ETH. And then I think we're ready to use our app now because we have some money. Let's come into our app. So we're still seeing a 0 here. That's because we are not connected to a specific account now. This account is an old account. So let's say we're connecting with the first one. Just going to close it. And then if we give this a reload, we should see a change in the address reflecting the address on our MetaMask. Just going to give it a quick reload. Let me see. I think my server is down. Okay. All right. Okay. So the first thing I need to do is actually migrate my. Okay, let me just do this. I almost missed a very critical point. Just gonna need to. I mentioned it, but then I didn't do it. So I'm gonna first compile my contracts. So we're compiling our contracts so that we're just checking for errors, checking that our contract it doesn't have any bugs. So we're getting positive feedback there. And then after compiling, I'm just gonna migrate. So this is a command that we execute when we want to deploy our contracts onto the blockchain. Just gonna do that. Before that finishes, I just wanna quickly show something. Let's please note the 100 ETH on the first account, and then we'll see what happens after our contracts are deploying. So our contracts are deploying here. So here's a summary of the command. We're having a total of 4 deployments, and then this is the cost here. So I think I mentioned that when you're making a transaction onto the blockchain, we are being charged a gas fee. So this is the gas fee here, and then so it's saying replacing token farm because I had imported those. So it's 3 of my contracts, my Ubuntu token, my Proti token, and the migration contract. I'm going to show these contracts just shortly. Then if you go to our Ganache, our blockchain here, so what's happening here is that we're seeing a decrease in our Ethereum for our first account. So what happens is that when we are deploying onto Ganache, so Ganache assumes it defines the first account as the owner account. So the owner account is the person who deploys the smart contracts onto the blockchain, and hence the decrease in the ETH here. Because remember, when we want to make a transaction in the blockchain, we pay a gas fee. And then if we look at our blocks here, these are our blocks. For example, if we can look at transaction 1, it's down there. Transaction 1 is it's a deployment of our contract. So this is the gas used here. It's basically giving us different information about our transaction. And then we're having 8 of them, because it's interesting how we're having 8 of them, yet we're deploying only 4 contracts. But then that's because with each contract, so like a contract is really like a class. and a class is a constructor function. So the deploying itself is a transaction, and then the constructor function, because it gets automatically executed, that's also a transaction. So that's true transaction per contract, and we have 4 contracts. Hence, we're having 8 transactions in total. This is our transaction history. Then it's not showing the contract. I don't think it's the user interface does that. So there we go. So we have our contracts on our blockchain now, and we can quickly interact with our web application as soon as I have my server running. There we go. I'm just gonna see. Just gonna do this first. So npm, that's because I'm running my front end with React. Let's see how much time. Okay, within 21 minutes. I'm gonna be very quick from here. There we go. So we're still having that balance of 0 here. Let me see. TA. So this is because we were using a previous address for the blockchain that we just closed. So we're just going to need to import or rather log in using a there you go, an active account. Give that a refresh, and there we go. So we're having a balance of 100. It corresponds with the balance on our Ganache. So yes, so from here, what we do is, so the logic of the app is that you have tokens, and then you stake them onto the staking app. So this here is going to keep track of that transaction, and then you're going to earn your interest here. So let's say you want to stake 100 tokens, all skin in the game. That's what you're going to do, and then I just moved that to the side because MetaMask is just going to pop up here. I'm just going to do a quick stake. So there's MetaMask. So it says give permission to access your Pro-T, and then here's a transaction fee here. You're just going to confirm that as the user. So what we're doing with MetaMask, we are simulating an investor into our app, and then they're going to confirm again. And here's the gas fee that I touched on again, 0.05 ETH. Then confirm that. So now here's an interesting thing here. Okay, maybe not so interesting, but we staked, yet we staked 100 Pro-T tokens, yet we still have a balance of 100. So it's like the blockchain is, it's developing, but it's still a bit slow as of now. So I'm just going to need to give this a quick refresh, and then there we go. So now we don't have anything in our crypto wallet, but then we have because we've deposited everything into our account. So that's the staking part. That's the staking part right there. And then if you want to unstake, you're going to click there, and then you confirm that transaction again on your MetaMask wallet. And then we need need to give it a refresh again because it's still in my staking balance and not in my account. And there you go, it's back in my account again. So now that's the staking and unstaking process that we just reviewed now. And then now I just want to show the rewarding of the balance. And I'm gonna pop up my terminal quickly to do that, because I can't do that via my user interface, because think about it, like I'm earning interest and I don't have, as a user, you don't have control over that. Like you can't make that process happen. So that's going to be the responsibility of the developer or whoever deployed the contract. So they're going to set like a period over which you're going to get your interest. So I'm going to do that via my command line because that's not available to the user. So I'm just going to, but then in order to get your interest, we need to have something in your staking balance. I'm just going to stake first. Quickly confirm that. Confirm again. Okay, quick refresh. There we go. So it's back in my staking balance, and then I'm just gonna fire up my command line now. Let me see. Okay, I'm just gonna need to open a different command line because if I close this one, it's gonna stop my entire app. All right, and then when I'm in my directory here, I'm gonna execute 4 scripts. So what is this? What is random? What is this random command? It's not magic really. So what I'm doing, I'm just executing a JavaScript application that is in my scripts folder. So the issue token file is the one that is responsible for the issuing of tokens, as in like the payment of the interest. So I'm executing that now. Get feedback from that. All right, so I'm getting feedback that the tokens are issued. So since the tokens are issued now, it's saying tokens are issued, I need to see a change in my Ubuntu tokens, because those are the ones I'm earning interest in. So still like that, I need to give it a refresh. And then there we go. So my Ubuntu tokens is 100 now. It's interest, it's 100 interest. I think it's a very generous bank, I would say. It gives you 100% interest. But yeah, you can set that to be any percentage really. I just went to the 100 just for testing purposes. And then if you want to, like this, let's say this was the first month, you earn 100 Ubuntu, and then the second month again, you're gonna run that. developer is going to be responsible for declaring the period, after which the script is going to execute. So we're getting a positive feedback again. So that should show us it's 100 now. We should see a change. And then there we go. Yes, so that's essentially, and then the investor can withdraw capital. You can withdraw your capital. So I'm going to withdraw your Pro-T tokens. Confirm that. Okay, then refresh. And there we go. We're back to 0. And then our thing is still remaining in our account. But yes, essentially that's the short demo of the app itself. Just trying to keep this as short as possible. Let me just check the time. I'm already on 31 minutes. Maybe for the next 5 minutes I can go through the code itself. And let's see. Come back here. Using my Visual Studio Code. So here's my code here. As I said, I was using Solidity in my backend and JavaScript in my front end. So these are my contracts here. So this is my Pro-T token. This is how you create a token. It's a standardized way. So we use the ERC 720. I think it's ERC 721 protocol now. It's basically a guideline that describes for you how a token is supposed to behave. For example, balance off, you seeing, so you with this method here, no, rather it's not a method, it's a variable. For example, this transfer here, transfer function, you gonna provide the address to which you want to transfer your Pro-T tokens and the amount of Pro-T tokens that you want to transfer. And then this require here, it's like an if-else statement in other languages. So this is required that the balance of the sender. So message.sender is a global variable in Solidity, and it refers to the person who calls a particular function. So the balance of that person is supposed to be greater than the value that they want to send. And I think it makes sense. Like you can't send 20 Ubuntu tokens while you have 10 Ubuntu tokens. So this is essentially what the statement here is saying. And then there's an entire process that happens after that, which is my seeing by this decrementing operation here. That means we taking the balance of the sender minusing the value that they sent. That's just one example of the functions. Same thing happens with our Ubuntu token. It's a token as well, so it's not different from the Pro-T token. It's just a different name, but then they function the same way. Then this is our main app here, token farm. So this is where most of the logic happens. For example, here's the staking function and then staking function. And then just to keep the video as short as possible, I mean the code is going to be available in my GitHub. But to keep it as short as possible, now I'm just going to move to the front end, because really that was or rather, let me just touch on this part here. So when you're running our migrations, we execute this file here. So this is the file that when I was executing Truffle migrate, this is the file that gets executed, and then it takes everything to the blockchain. You can see the different tokens here, tokens in the token farm itself. So that's the file that gets executed, and then the script, the file that I was executing for issuing the tokens is this one here, scripts. It's in my scripts folder, and then ABIs. What these are, so these are JSON files that get created when we migrate or when we deploy our tokens. So basically, what in tokens or contracts. So basically, what an ABI is, it's really an interface of how our smart contract works. It's a JSON representation of my smart contract. Really, exactly the way I'm putting it, it's like you're translating the smart contracts into a different format so that JavaScript can understand it. So for example, this here is the ABI file for my Ubuntu token. And here's my Ubuntu token here that I wrote in Solidity. So this and this here are the same thing. Just that this one is one that we're going to use to create our smart contracts and interact with them in our user interface using JavaScript. And then same thing for each contract. I'm really sorry to be rushing so much. It's just I'd like to keep the video as short as possible for the viewer. But yes, essentially that's the summary of the back end. And then with my front end, this is the main here. So with my front end, for example, you see this part here. This is where we see, this is the part that shows us the balances. And then on submit, so this is a click. It's the staking tokens part. It's the staking tokens part. So when we're clicking on that, here's the logic that happens. So this is the props of stake tokens that gets staked. This is what happens in our front end. That's our front end. This is my navigation bar. Nothing really hectic, I would say here. It's just the logo in the account, because we're fetching information from our blockchain and then loading it onto our front end, hence the state variables here. Similar to how when we're working in Web 2.0, when we're using an external resource, maybe an API, then we're gonna store all that information in our states in JavaScript. And that is shown by these two functions here. So sorry about that. So the first thing we do, okay, I hit something right there. So this is, it's quite a, it's quite verbose. That's why I'd like to go through everything, but just for time's sake, I'm just going to summarize all of this here. Summarize down to this function here. So the first thing that we're going to do is we're going to create an instance of the blockchain, and then we're going to load the blockchain data. Loading the blockchain data, because remember, we deployed our smart contracts onto the blockchain, and we need all of that information. So this is the logic here. All of these functions down here, they do all of this. Yeah, just for summary's sake, I can leave it here, but I think I covered at least mostly of the parts. I'm definitely going to, the link is going to be available on my portfolio site, and also, yes, on my portfolio site you can find my contact details. You can either shoot me an email or contact me via the social media accounts that I tagged on there. And then if there's any questions, they're more than welcome, really. And it would be interesting to hear those questions, because blockchain development currently is still under hyper development, So literally, you can have a function. You can be doing something in a certain way this week, and then the next week it's deprecated. See? So if you have questions, and if you also have knowledge to share in terms of blockchain development, definitely I would appreciate a hi. Yes, it'd be interesting to have someone to just bounce around those ideas with, help each other keep in track. I'd like to just end it here. Thank you very much for joining me today with the demo and the code walkthrough, and see you on my next video. Thank you.